Hi, and welcome to a Papetti Math YouTube video tutorial where I'm going to be teaching you, yes, you, Algebra 1. And in this video, we're going to be looking at exercise number 2 in chapter 11 on recursive sequences. And it says recursive sequences could take the form of arithmetic sequences, where you're adding the same amount over and over, geometric sequences, where you're multiplying by the same amount over and over, or as you saw in exercise number 1 with the Fibonacci sequence, neither of those two types. So use the following recursive formulas to find the nth term of each sequence. So we're given here that in part A, that a sub n is equal to a sub n minus 1, which means the previous term, minus 6. It tells you what the first term is and to find the fifth. So before we can find the fifth term of this sequence, we need to find the second, the third, the fourth, and then the fifth term. So we have to do quite a bit of work in order to find this fifth term when we work with recursive sequences. So the first thing we're going to do, now that we know the first term, is we're going to find the second term. So everywhere we see an n, we're going to put a 2. So we're going to have a sub 2 minus 1 minus 6. Now that's going to simplify to a sub 2 minus 1 is the same as a sub 1 minus 6. And a sub 2, a sub 1 we know. We were given in this information right here that a sub 1, our first term, was equal to 2. So this is going to be the same as 2 minus 6. And we could definitely simplify 2 minus 6. And now that we know that our second term is going to be negative 4. Pause right there. Take it in. Because now what we need to do is we need to find our third term. So we're going to find our third term by taking this formula again, and everywhere we see an n, we're going to put a 3. So we're going to do an a sub 3 minus 1 minus 6, and that's going to simplify to a sub 2 minus 6, and that there will simplify, well, let's see. We know that a sub 2 now is negative 4. We just found that out. But without that piece of information, we wouldn't know what to substitute in there. And that's why we have to go in order of our terms to get to the fifth term. So we have a sub 2 minus 6, and that's going to be the same as negative 4 minus 6. And a sub 3 will then be negative 10. All right. So now we're going to look at a sub 4 up over here. And we're going to do a sub 4 minus 1 minus 6. Again, just substituting into the formula that we're given to get to our fifth term. And we're going to do a sub 4, and that's going to be the same thing as the third term minus 6. And we just found out down here that our third term was negative 10 minus 6 is going to give us a fourth term of negative 16. And finally, we have a sub 5, which is what we're looking for, our fifth term. And we're going to do a sub 5 minus 1 and all of that minus 6, which would be the same thing as 5 minus 1 gives us a sub 4 minus 6. We just found out right here that a sub 4 was equal to negative 16 minus 6. And that means that a sub 5 is negative 22. So our fifth term in this sequence is going to be negative 22. All right, part B. Oh, geez, we're going to have to find the sixth term here. Hopefully it won't take up too much space. But let's see what we have. We have a sub n equals a sub n minus 1 times 4. It tells you that the first term is 0.5. Find the sixth term. So we know the first term. That means we could go straight into finding the second term. And when we substitute 2 in for n, we're going to get 2 minus 1. I'm going to just automatically say that 2 minus 1 is 1 times 4. And a sub 2 will be, well, we know that this is 0.5 times 4. And a sub 2 is going to be, well, 0.5 times 4 is 2. All right, we're ready to find our third term now. A sub 3 is going to be a sub 3 minus 1 right here. A sub 3 minus 1 would give us 2, a sub 2 times 4. Well, we just found out that our second term is 2. So we're going to replace a sub 2 with 2 and multiply that by 4. And we're going to get that our third term is equal to 8. We're going to go and move on to our fourth term. And to get our fourth term, we're going to do a sub 4 minus 1, which would be a sub 3. And multiply that by 4. So we're going to get our fourth term is going to be 8 times 4. And we know that 8 times 4 is 32. Almost there. Now we're looking for our fifth term. And to get that, we're going to do a sub 5 minus 1 according to our formula. So that's going to be a sub 4 times 4. And we just found out down here that a sub 4 was 32. So we're going to do 32 times 4. And that's going to give us a fifth term of 128. Whew. Now finally, we're on our sixth term, and that's what we're looking for. So to find our sixth term, we're going to do a sub 6 minus 1, which is a sub 5, and multiply that by 4. We just found out that our fifth term was 128. We're going to multiply that by 4. And we're going to get that our sixth term is equal to 512. All of that work to find out that our sixth term of this sequence, of a recursive sequence, is 512. If you need to keep looking at this work, pause the video, because right now we're going to scroll on down to part C. A little bit different looking here, because now we have ends as subscript and also up as a product of 2 with 2. So we're going to start off with this formula here. We're going to find the fifth term given the first one. So since we know the first one's 3, we're going to go right into the second term of this sequence. And every time we see an n, we're going to put a 2. So we're going to do 2 times n, but we're going to replace the n with 2, times a sub n minus 1. So 2 minus 1 will give us 1. Okay. So we're going to have a sub 2 is equal to, well, 2 times 2, we could do 4 times, we know a sub 1 is 3. And that's going to mean that a sub 2 is going to be 4 times 3, which is 12. All right, ready to go to a sub 3. A sub 3 here is going to be every time we see an n to put a 3 now. So we're going to do 2 times n, so 2 times 3, times a sub 3 minus 1, which is a sub 2. So a sub 3 is simplify 2 times 3, I get 6, times a sub 2 we just found was 12. We have 6 times 12, which is 72. And now we're ready for a sub 4. We're going to do 2 times 4 times a sub 4 minus 1, which is 3. And that's going to be the same as a sub 4 equals 8 times 72. And you're just going to go ahead and you're going to multiply 8 times 72, and you will get 576. We're looking for our fifth term here, so we're almost there. We're about to arrive at our fifth term right now, where we're going to do 2 times 5 times a sub 5 minus 1, which is 4. And a sub 5 is going to be equal to 10 times a sub 4 we just found was 576. And our fifth term of this sequence is 10 times 576, which is 5,760. So again, we worked through this, finding our second, third, fourth, then finally fifth term. And our longest one yet, in part D, we have a sub n equals this formula, and we have to find the seventh term of this sequence. So let's get right into it, and then we are done with recursive sequences. Now, we're going to start off with a sub 2 because we're given a sub 1, so our next step would be to find our second term. So we have a sub 2 is equal to 3 times a sub 2 minus 1 right here in the formula, so that's just a sub 1, plus n, which is 2. Okay, so we're going to simplify this to 3 times, well, we know -1 is our first term, plus 2. And so a sub 2 is going to give us a -3 plus 2, and that's going to be -1. Interesting. Our second term is the same as our first. Let's see if this continues. We have a sub 3 is going to be 3 times a sub 3 minus 1, which is the same as a sub 2, plus n, which is now 3. A sub 3 will be 3 times, well, we just saw that that was -1. So 3 times -1 plus 3. And a sub 3 is going to be -3 plus 3, and that's going to give us a total of 0. We're on to a sub 4 now. A sub 4 is going to be 3 times a sub 4 minus 1, which is a sub 3, plus n, which is 4. We're going to have a sub 4 is equal to 3 times a sub 3 we just found was 0, plus 4. And a sub 4 then is going to be 3 times 0, 0. 0 plus 4 is 4. Ready for a sub 5. Almost there. A sub 5 is going to be 3 times a sub 5 minus 1, which is 4, plus n, which is 5. A sub 5 is going to be 3 times, well, we just saw a sub 4 was 4. 3 times 4 plus 5. And a sub 5 is going to be 12. 3 times 4 is 12, plus 5 is 17. 2 more. So we're going to go up here. We're going to do a sub 6. Lots of work for a recursive sequence. A sub 6 is going to be 3 times a sub 6 minus 1, which is a sub 5, plus n, which is now 6, because we're looking for our sixth term. A sub 6 will be 3 times our fifth term we saw was 17, and plus 6. And this is going to give us a sixth term of 51 plus 6, which is 57. And that brings us to our seventh and final term that we are looking for. We're going to have 3 times a sub 7 minus 1, which is a sub 6, plus 7 now, because that's our n value. And we're going to have a sub 7 is equal to 3 times, well, our previous term was 57, plus 7. And 3 times 57 will give me 171, plus 7, which will give me a seventh term of 178. It's my seventh term of this recursive sequence. Now again, if you look back, a recursive sequence does involve a lot of work just to get to a small number term in the sequence. We only got to 7th, the 5th, the 6th, and the 4th term here. We didn't get to the 30th or the 40th term. But you'll probably never be able to ask, you'll never be asked to get to the 40th term of a recursive sequence, because that would just be absurd. You'll most likely be asked to find like the 5th or 6th term. Some cases maybe the 7th. So if this video was helpful, please give it a thumbs up below to let me know that this video was helpful to you in your process of learning Algebra 1. You are now ready for Chapter 12, the final chapter of Algebra 1 that deals with statistics.